Hi everyone. Okay, so we are in Module 3, Topic 3, Lesson 1. And this lesson is on graphing. Every graph tells a story. Today we're going to be talking about independent and dependent variables. Hopefully you already watched the video that I had an additional worksheet on independent and dependent variables. If not, you should go back and find the link for that and watch that first, please. Okay, so the learning goals: identify the graphs of situations, determine whether graphs are discrete or continuous, identify and use variables to define independent and dependent quantities in real-world problems, and we will write an equation in terms of two quantities: discrete graph, continuous graph, dependent quantity, independent variable, and dependent variable are our vocabulary words. So our review: use the given rule to complete each table. So rule 1, multiply by 3. So what this is telling us is that if we multiply by 3 here with our input, so we're putting a 3 in, or multiply by 3, what will happen when we multiply our input by 3? So 2 times 3, we call it our output, is a 6. So 2 times 3 equals 6. So for this column, it'll be something times 3 equals 9, or 3 times something gives us 9. So we get a 3. This column, 3 times 4 gives us 12. And 3 times what gives us 15? Right, 5. Okay, and you go ahead and try the next one. Notice we're adding 12. So if we're adding 12 to 6, what do we get? 18. Add 12 to what gives us 20? 8. 12 and 10 gives us 22. And 12 and 11, 12 plus 11, or 11 plus 12 gives us 23. Okay, so hopefully you did well on that. Okay. So we're not going to look at the getting started. We're going to hop right on over here. So this says match and analyze. In this activity, you will match a specific graph to a real world problem situation. You need to cut out the graphs and scenarios located on pages 477 through 485. So we're going to tape each graph in the box with the appropriate scenario. Basically, we're going to match them up, label the x's with appropriate quantities and units, and then we'll figure out how we determine which is which. So I'm going to pause while you go ahead and get those cut out. Basically, at the end, you should have graphs that look like this cut out. Some are words and some are actual graphs. So you go ahead and do that. I'm going to pause while you do. Okay, so I have the graphs cut out here, and I have the ones that are actually the pictures of the graphs laying here in front, labeled A through F. And then I also have the cards cut out to match up. You don't necessarily have to cut these parts out if you didn't. If you only cut out these, that's fine. You can just tape these ones on the page right next to this that's in the book. If you did cut them out, that's okay too, and we'll just pair them up. Either way works. So let's see what we can do here. So you are draining a 200-gallon fish tank at a rate of 10 gallons per minute. How much water remains in the tank at a specific time? So we need to look at these different graphs and figure out which one might be showing us draining a 200-gallon fish tank. Looks like it's at a constant rate of 10 gallons per minute. So if it's draining, it's decreasing. It's not increasing. So this one looks like it increases, then decreases. This one increases, stays the same, increases, stays the same. This is a decreasing, so that's a possibility. C and E are increasing, F is decreasing. Now, when you're draining a fish tank, it's probably going to drain at a steady rate. B doesn't show a steady rate, but F does. So I'm going to match that one up there. Okay, so this one says t-shirt sales. Your club is selling t-shirts. There's a $25 design charge plus the cost per t-shirt. What is the total cost to order different numbers of t-shirts? So as I think about this one, when I'm thinking about how it might look on a graph, and I am thinking about the graphs that I see here, I'm immediately going to eliminate this one because I don't think it is going to go up and then back down. And I don't think anything's going to hold steady in this one. So I think and it's not going to decrease. So I'm thinking C or E. So let's try to figure out which one might this be. So it looks like E starts at the origin, starts at 0, 0. But C doesn't. C starts at 0, and then it's up a couple. Now this y-axis isn't labeled, but I suppose that could be the $25. So then for 2 t-shirts, it would go up a little bit higher than that. I suppose if it went up by 25s for every 2, then 4 t-shirts would be at the 50. So $12.50 a shirt plus the $25. Yeah, I think that looks right. Okay, so we're going to go with that one. So the video kiosk charges $2 for movie and game rentals. How many movies and games can you rent for different amounts of money? So $2. So again, I think that's one that has a steady rate. Every game is $2. Nothing's decreasing. So I think we're looking at this one. Let's just double check that. So it's 0, 0. So I guess if I don't rent any video games, I'm not charged anything. So 0, 0 makes sense. Then if this represents one video game and $2, so if it goes over here for 2 and then up for $4, yeah, I think that one's it. Nice, we've got that one done as well. Team party. You have cookies for your team party, but you don't know how many of your teammates will show up. How many cookies will each teammate receive if everyone receives the same number of cookies? Oh, let's see. So this one I don't think can be a continuous line because I can't have part of a person, right? So thinking it might have to be this. Let's see if it makes sense. So if this was the number of people and this is the number of cookies, right? Because the number of cookies someone receives is going to depend on the number of people, and our x-axis is our dependent. So let's see, if there's 2 people, they get 12 cookies, is what this is saying. Well, what if there's 4 people? 4 people is 6 cookies. Well, 4 times 6 is 24. Is this 24 as well? 2 times 12? Yeah, so it's 24. What if there's 6 people at the party? 6 people would each get 4. That's still 24. 8 people, it should be up to 3, and it is. Oh, good. This one's definitely that. All right, 2 more. Rainy day. When you left home, the rain was falling at a steady rate. Then it stopped raining for a few hours before a sudden downpour. Finally, it stopped raining. How many inches of rain had fallen at different points of the day? And then we also have your toy. You launch a toy rocket into the air from the ground and observe its height through its entire flight. How many feet high was the rocket at a specific time after launch. Okay, so if rain is falling at a steady rate, that means my line will be going in one direction at a steady rate. So, for example, this from here to here, it goes up one and over one, up one over one. Okay, so that's showing a steady rate. Now, just because we're saying rain is falling doesn't mean that the line should be going down. Because if this is the amount of rain and this is the time, so after 2 hours, let's say this is 1 inch here, 2 inches, 3 inches. So after 2 hours, there's 2 inches. After 4 hours, there's 3 inches. That makes sense. Then it stopped raining for a few hours. So that would be here. The rain is holding steady, no additional is falling. So we would have had whatever this number we would label it here is. And then it stopped raining for a few hours before a sudden downpour. So if it's a sudden downpour, it's going to increase the rain amount very quickly. This line is more steep, which makes sense. And then before it had stopped raining, so it stopped here and went straight across. Definitely there. Does this make sense for the toy rocket? Okay, so you launch it, it's on the ground at 0. Its height would be this high peak, and then comes back down to the ground. Now, this isn't the trajectory path of the rocket. It's just at a given moment in time how high it was. So if this is the time and this is the height at 2 minute, it was probably seconds. At 2 seconds, it's here. At 4 seconds, it's this high. At 8 seconds, it's this high. And then it starts to come back down. And by 16 seconds, it's all the way back to the ground. Okay. Hope you did well on that. I'm going to pause here again for just a moment. Okay, so back to the textbook pages. I'm here on page 463. I just want to talk through number 2. It's quite a bit to write out, so I just want to have a bit of a discussion about it. So it says, how did you determine which graph matched which scenario? So as we were reading through those, I thought about the quantities in each scenario and how they related to each other. Talked about whether one was constantly increasing or decreasing, or if it increased some, then held steady and increased some more, if it stayed constant. I also thought about whether the numbers that we were talking about could be continuous or if they could only be like whole numbers, like we couldn't have part of a person. So that didn't really make sense in that. So we kind of used the scenario itself and what we understand about the application of the numbers within that to determine whether we were looking for a graph with a line or with individual points, and we were able to get things matched up in that way. Okay, so let's turn the page. Okay, so this says a discrete graph is a graph of isolated points. Often the coordinates of those points are counting numbers. A continuous graph is a graph with no breaks in it. Each point on a continuous graph, even those with fractional numbers as coordinates, represents a solution to the graph scenario. So just to give an example, and this would have been a continuous graph, while this one is a discrete graph. So continuous and discrete. So then it wants us to go through and says which graphs are discrete graphs and which are continuous. How does the scenario inform you that the graph will display discrete or continuous points? Again, we just kind of talked about that. If it's just individual whole numbers, it's going to be discrete. So which ones are discrete? We're just going to label this discrete and continuous. And then let's take a look at them. So we had B. So we said B is among the discrete. D, that's a continuous line. We're going to put that down here. C, it's individual points. Excuse me. F, yep, continuous. Yep, discrete. So that cough, guys. So discrete is B, C, and E. Continuous is A, D, and F. Okay, to complete the rest of the question here, it asks, how does the scenario inform you that the graph will display discrete points or be continuous? So for the discrete, we knew that, and yes, you'll write this, the independent quantity in each graph was measured by counting numbers. For example, the number of teammates was one, the number of shirts was another. For the continuous, the independent quantity in each graph, I don't know if you noticed, it was time. And time can be represented, and it can be represented by any rational number. So in other words, it doesn't have to be a whole number. So like the amount of time it took for the fish tank to drain. So that didn't have to be a whole number. So it could be 2.5 minutes or 3.25 minutes. The length of time that the height that the rocket was in the air was the dependent, the time was the independent. So it could be 3 minutes. We could have figured out where it's at 3.5 minutes or 10.5 minutes, and so on. It says, which graph or graphs represent equivalent ratios, and how does the scenario inform you that the graph will display equivalent ratios? So remember, equivalent ratios from another unit, we know that that has to go through the origin. So that one did. Okay, so, and I think that's the only one we have. Yeah. And E was, what one was that? So I think that was the video game. So this one is Graphy. So the scenario states a unit rate because it told us that it was $2 for movie and game rentals. So for one movie or game rental, it was $2. And we know that when we have a unit rate, I can multiply by the unit rate to determine the total cost. I'm going to move this up so that you can finish getting that copied. And while you do that, I'm going to label this here. Okay, so and as you can see here, so I just started to label this. So this would be number of games. And this amount over here is the cost in dollars. I'm just going to put a dollar sign. They don't really give me much room to write that. So we can see that we can determine a unit rate. So 3 games at $2 each should give us a point at 6, and it does. Okay, excellent. Moving on. Finishing up activity 1 here. It says consider the graph in the rainy day scenario. Assume that 2 hours after you left home, 1.5 inches of rain had fallen. Explain how the graph illustrates that the rain fell faster later in the day than it did at the beginning of the day. So if we look at that, which was this one, what do you notice? So this is as the time is going on. So this is time. And this was the measure of rainfall. So as the day went on, we can see that between 8 and 11, it's much steeper. So that tells us that a lot more rain fell in that shorter period of time. So the graph is steeper. So this is time in hours. Between 8 and 11, and it's really not like time of the day, it's how many hours from the time that they assume 2 hours after you left home. So this is 2 hours after you left home. Okay. So hours. And then it is actually I went between, then between 0 and 4 hours. HRS period hours. Describe when it was not raining in terms of the time. So it wasn't raining when it's going straight across. So it wasn't raining between 4 and 8. And it wasn't raining. Let's see. This is 11. So after 11 hours. Okay, excellent. Next, it says, consider the graph in the toy rocket scenario. The rocket reaches a maximum height of 256 feet. Describe the shape of the graph. So then this right here coming across would be where 256 feet is. So we'd have to figure out how they have this broken up. There's 10 spaces between here and here, so each one is 25.6 feet, each line. So it just says describe this shape of the graph, though. So there's no straight lines. That's one thing that we can say. Which tells us that it didn't go up or down at a continuous rate. So it didn't ascend or descend. Some vocabulary words in there. So it has a curve. And it goes up. Reaches the highest point. Which they're telling us is 256 feet. And then returns back to the x-axis. We can really just say it is an upside down U. Okay, so when was the rocket rising? When did it start to come back down? It looks like here it was at its peak, so it was rising for, let's think about this. What do we think this time is broken up into? I don't think it'd be minutes for a rocket to go up for 8 minutes. Just doesn't seem right. So must be seconds, rising for 8 seconds. Okay. Consider the graph of the t-shirt sales scenario. Suppose there's a minimum order total of $100 when you're ordering the t-shirts. Describe the number of shirts and that you must order to meet the minimum order requirement. Okay, so let's find the t-shirts. That was the one that was also the dots. Yep, right here. But it didn't start at 0, 0. So we said this must be $25 here. Because even before you order any shirts at all, there's a $25 fee. So if every other line then goes up 25, 50, 75, 100, 125. Okay. So it says, suppose there's a minimum order of 100 shirts. Describe the number of shirts that you must order to meet the minimum. So we have to spend at least $100. So if we go across here at the $100, use another one to do this. If I go across at the 100, And then I can see this dot here. Where does it come down at? Yep, 12. So we must have to order. So this is the number of t-shirts. So from this scenario, we we know the y-intercept. Remember, that's where a line crosses the y-axis, so right there must be 0.25, meaning there is a $25 charge before any shirts are ordered. So for a minimum order of $100, 12 shirts must be ordered. And it's really 12 shirts, I can say, or more. Okay, and again, you can pause this if you need to finish filling it out. I just want to peek here. Okay, and that ends activity 1. So that's where I am going to stop at for today. We'll put activity 2 on a different video. Just giving you another minute or two to copy here. Okay, so I'm going to turn it off. If you're still copying, go ahead and just hit pause right now. I'll give you a second to do that as I'm hitting end.